Welcome everyone. We are discussing second order derivative. Today I will discuss miscellaneous problem of second order derivative. These problems are important for board as well as competitive exam also. So look, problem number 1 and 2. Problem number 1. X equals to sin t, y equals to sin pt. Prove that 1 minus x square into y2 minus xyy plus p square y equals to 0. And second one exactly same. X equals to tan t, y equals to tan pt. Prove that 1 plus x square into y2 plus 2 into x minus p square into y1 equals to 0. Here x and y are related to that is parametric function. So you can find dy dx, then double derivative, putting value of y2 and y1, you get result. This is direct method. Now look, since final result is independent of t, so it will be simple if we eliminate t, then perform derivative. So I have already solved types of problem number 1. So we consider problem number 2. They are of same type. Eliminate t, then perform derivative. So x equals to tan t, y equals to tan t. So our main aim will be to eliminate t. To eliminate t. So what is t? T equals to tan inverse x. Now what is y? Tan p tan inverse x. So this is our main aim, to eliminate t. So y is expressible in terms of x. Then perform derivative. dy by dx equals to 1 this is sec square p tan inverse x. Sec square p tan inverse x. Then derivative of p tan inverse x. P by 1 plus x square. So look, dy dx, derivative of tan is sec square, then derivative of argument. And exactly same, avoid cosine. So 1 plus x square into dy dx equals to p sec square tan inverse x. You know value of tan. So express it in terms of tan. So 1 plus p tan inverse x. So 1 plus x square into dy dx, p into sec square p tan inverse x. So sec square is 1 plus tan square. So p unchanged. 1 plus, what is tan pt? Tan p tan inverse x is y. This is y. So we are getting 1 plus, this is y square. 1 plus y square. So now differentiating again with respect to x. So call it 2. So this is simplified form. Now 1 plus x square unchanged. This is d2y dx2 plus 2x into dy dx plus p into 2y dy dx equals to 0. So this implies 1 plus x square into y2. Then this is 2x minus 2y into y1 equals to 0. Double derivative is y2, dy dx is y1. So 2x minus 2y equals to 0. So take 2 common. So 2 into x minus dy into dy dx equals to 0. So this is our final result. Now 1 plus x square plus 2x into 1 minus dy, correctly, this will be 1 minus dy into y1 equals to 0. So eliminate t, then perform derivative, you will get direct result. Now problem number 3. So this is of competitive JEE main, but look, in competitive exam it will be given in this form. Value of 1 minus x square into y2 minus xy1 equal to 4 minus 4, 2, 3 in this form. It is of MCQ type. So y equals to sin inverse x whole square plus cos inverse x whole square. So for it 1. Now what is dy dx? Dy by dx equals to 2 sin inverse x into root under 1 minus x. 2 cos inverse x. This will be plus, but derivative of cos is minus. So that is why this is negative. Now to avoid cosine, you multiply it by 1 minus x square. So 2 sin inverse x minus 2 cos inverse x. Then you can take square also, or you can perform direct derivative. So suppose we are not taking square because this one is not simplified. So differentiating both sides, WRTX. So root over 1 minus x square into d2y dx2 plus half into root over 1 minus x square into minus 2x, then dy dx unchanged. So half 1 minus x square whole to the power minus means this, then derivative of 1 minus x square, dy dx unchanged. And this is 2 root over 1 minus x square, and this will be plus root over 1 minus x square. Now final result is without root over form. So multiply throughout by root over 1 minus x square. So 1 minus x square into d2y dx2 minus x, 2 cancel, dy dx. This will be cancelled, 2 plus 2 is 4. So 1 minus x square, final result y2 minus xy1 equals to 1. So this is problem number 3. So they are of same type. Now problem number 4. So y equals to log x plus this total whole square. Mind it, y equals to log x square. Then you can simplify it. 2 log x. Y equals to log x whole square. You cannot take 2 before log. So this is total whole square. So this should be noted. Now y equals to this. So call it 1. So what is dy by dx? 2 come forward. This x square. So 2 come forward. Power diminished by 1. So x plus root under x square plus 1 into d dx of log x plus x square plus 1. Now differentiate this one. So 2 log x plus root under x square plus 1 then derivative of this one. We have done it several times. So log 1 by this derivative of argument 1 plus r into root over 1 plus x square into x. So 2 log x plus root under x square plus 1 by this. Then if you simplify, 2 cancel, root over 1 plus x square is LCM, x plus x. So this to be noted. Derivative of log is simplified from 1 by root over 1 plus x square. Now 1 plus x square is at the denominator. So try to avoid cosine. So that is why we are writing it 1 plus x square into dy dx. This is 2 log x plus root over x square plus 1. So from 1, log of y equals to this. So what is root y? Root y. So this is 2 into root y from 1. Because log of this, y square equals to a. So y equals to root over a. Now to avoid root over sign, you have to take square on both sides. So 1 plus x square into dy dx whole square. 4 dy. So this is, now this relation is independent of root over. So I have already stated that if we take square, then 2 dy dx will be cancelled from both sides. So this implies 1 plus x square 2 dy dx into d2y dx2 plus 2x into dy dx whole square equals to 4 dy dx. So finally what you are getting, 2 dy dx, 2 dy dx, 2 dy dx will be cancelled out. So finally we are getting 1 plus x square into y2, 1 plus x square into y2 plus xy1. So 2 dy dx cancel. So we are getting the result. So same technique. Next, x equals to y to the power 1 by n, y to the power minus 1 by n. Prove that x square minus 1 into y2 plus xy1 equals to n square y. This one is general. Now, if y is replaced by suppose 1 by 3, then what is the result? X square minus 1 into y2 plus xy1 equals to 9. Now, problem number 6. If cos inverse y by b equals to log x by n whole to the power n, prove that x square y2 plus xy1 equals to n square y equals to n square y. Now, we are considering these three two problems, 5 and 6. So, we first consider problem number 6. Now, this is cos inverse. So, listen it. It is cos inverse y by b equals to this. Result is in terms of y2. So, our main aim will be to express the given function in terms of y, if y in terms of f, if possible. So, cos inverse this. So, y by b equals to cos. Now, log x by n whole to the power n. By rule of indices, this is cos n log x by n. By rule of indices, it is again. So, what is y? B cos n log x minus n log n log n. So, this is expression of y in terms of x. So, this is our main idea. Now, y is expressible in terms of x. So, this is our main aim. So, differentiate y. So, dy by dx equals to minus b sine n log x minus n log n. Then derivative of argument, this is n by x. N cosine n log n is constant. Now, to avoid cosine rule, x into dy dx equals to minus nb sine n log x minus n log n. So, for it, now differentiate again with respect to x. So, x into d2y dx2 plus dy dx. Now, minus nb is constant. So, derivative of sine is cos n log x minus n log x. Then derivative of argument. So, n by x. So multiply throughout by x. So x square d2y dx2 plus x dy dx. So minus n square into b cos n log x minus n log n. So this one is x. Now what is value of b cos n log x minus n log n? So this is y. So this is minus n square y. Therefore, finally we are getting x square y plus xy1 plus n square y equals to 0. So x square y2 plus xy1 plus n square y equals to 0. Let us verify again. Y by b cos. So derivative of cos is minus. The derivative of sine is, so 1 minus will remain. So actually it will be n square y equals to 0. So you complete problem number 5. Expressing y in terms of x. So this is most important problem for JEE Main. So this one is general problem. 1 by b n is replaced by c. So today through this video I have solved some important problems of JEE Main and Wbjee. So thank you for today.